This is a typical cubic curve. It has a minimum point here, a maximum point here, crosses the y-axis at y equals 3, and it crosses the x-axis here. Now the places where a curve crosses the x-axis are called the zeros of the function, and this one only has 1. The equation of this curve is quite an awkward equation there. Now I'm going to change it so it has a much more useful form. Now this equation goes through -1, +1, and +3, and its equation is now this one. And now you see that it crosses the x-axis 3 times, so we would say this has 3 zeros. Now watch what happens as I move this point. Now that point now goes through 2, and the equation is now this equation. It goes through -1, +1, and +2. Now I'm going to move this one towards this point here, and we'll see that they coincide. Now the curve still has 3 zeros at this point, but when they coincide, it looks as though there are now only 2 zeros, but this one was the result of 2 zeros which coincided, so we call this one a double zero. And the equation of this curve now is this one here. Now carrying on, now we have 3 zeros again. And now this zero goes right through the origin. So the curve now has 3 zeros, -1, x equals 0, x equals +1, which is this equation here. Now watch what happens when I move this one to the right and this one to the left. Now the 3 zeros are going to coincide at the origin. And this is the very basic cubic curve, which is just y equals x to the power 3. Now I'm going to add in an x term and make it into this equation, because this equation is really y equals x cubed plus x. And we can see that the curve has sort of stretched out. Now I've got to stretch it out more and make it into the next equation. And now it's hardly recognizable as a cubic curve, but it is still cubic. And if I continue, it seems to get stretched more, but it never quite gets straight. It is always curved.